Hello students, today we are going to discuss chapter solid state from 12th chemistry, and from this chapter the very important concept which is crystal defects that we are going to discuss today. So first of all we will see some important points regarding crystal defects and then we will see the types one by one. So let's start. Basically what is crystal defect or crystal imperfections? That is irregularities in the arrangement of constituent particles. So if a solid crystal have irregularities in the arrangement of their constituent particles, crystal defects are formed. Second point, which are basically natural occurring. So these crystal defects occur naturally during the process of crystallization. But nowadays, these crystal defects intentionally created. Why? Due to their very important and desired properties. So these are important points regarding crystal defects. So they are nothing but irregularities in the arrangement of constituent particles. They occur naturally during crystallization process, and nowadays they are intentionally created in the laboratories due to some important properties. Next, there are types of crystal defects: point defect, line defect, and plane defect. As the name suggests, the defect regarding point, that is nothing but point defect. Defect of line occur in a solid crystal, which is line defect, and regarding plane, surface or plane, is called as plane defect. But in 12th syllabus only point defects are discussed in detail. So we are also going to discuss only point defects in this particular video. So again, there are sub points under point defects, which are first stoichiometric, second impurity, and third non-stoichiometric. Okay. Next, we will see them one by one. So first of all, we will see what stoichiometric defects are. As the name suggests, what stoichiometry is, or what is stoichiometric? Nothing but chemical formula of a compound that shows fixed ratio of number of atoms or number of cations or anions. So this is nothing but fixed ratio of atoms, you can say. Fixed ratio of atoms. Now again, there are subpoints of stoichiometric. So first is vacancy defect. Vacancy defect. For this, I will draw a diagram of a solid crystal. Let's say this is a crystal and these are the constituent particles of that crystal. Now, if a particle misplaces its original site or the regular site from the crystal, then vacancy will be created. And then this defect is called as vacancy defect, which means during crystallization of solid, a particle is missing from its regular site, creating a vacancy in that structure. Then that defect is called as vacancy defect. Okay. Then, now what happens when a particle is missing? Due to this absence of particle, the mass of the substance will decrease, isn't it? Because mass depends on number of particles. As number of particles decreases, mass will also decreases. But what about volume? Volume will remain unchanged. Volume will remain unchanged. And what about density of that crystal structure? Density also decreases, because we know the formula for a density: mass upon volume. If mass decreases, density will also decrease. So in this vacancy defect, this defect basically due to missing of particle from their regular site from that crystal, and this defect is formed, and mass will decrease, volume will remain unchanged, and density will also decrease. So these are important points regarding every defect. So in every defect we will see these points: mass, volume, density, etc. Second type under stoichiometry itself, which is self interstitial. self-interstitial crystal defect. Now, under self-interstitial, there are two cases, I must say. So, case number one, again, I will draw a crystal structure for better understanding. These are the constituent particles. I have drawn extra particle here or here. So, what happens in self-interstitial crystal defect? Extra particles from other crystals, extra particles from outside of this crystal will enter and place interstitially. Interstitially means this places, this places, this places. So they place interstitially, and hence this defect is formed, is called as self-interstitial defect. Okay, this was case number one, that is extra particles are placed interstitially in the voids or interstitially. And second case, which is again I will draw crystal structure. These are the constituent particles. Now what will happen? The particles, the host atoms or the host particles will place interstitially, forming a vacancy. So here it is vacancy created. Why? Because particle from this side removes its position and place here, which is self-interstitially placed. So here this is also case of self-interstitial, but this is not extra particle. This is the particle from this side. It had just replaced its position and placed interstitially. So this is the case number two. This case, in case number one, extra particle was placing in self-interstitial places, but here the regular site particle misplaces its position, creating a vacancy, and takes a position which is self-interstitial one. Now, what will happen in case of mass, volume, and density? Volume will remain definitely unchanged. It will remain unchanged. Mass increases. Why? Because extra particle is there. Okay. And if mass increases, density will also increase. And in case of self-interstitial, mass will not increase, mass will not decrease, because the particle from regular site have just changed its position. So mass will remain same, volume will remain same, and the density will remain same. So all will remain same. So these are two types of stoichiometric: vacancy and self-interstitial. Then there are other types as well that we are going to discuss in our next video. Thank you.